There we go. All right. Are we live or we Memorex? Right. Who's old enough to remember that? All right. You got a few people. Okay. So today I'm going to talk about solid wall of C++ library. Oh, that's right. You can look up there. Okay. So this is me. I'm a retired grumpy old man stuff. Right. So I'm going to refer to this as libswoc generally. It's primarily a reimplementation or reversion of existing ATS libraries. So 90% of the stuff in here is a clone or a copy or redoing of something that's already in ATS. So it's not, in some sense, it's not that big a change. When I was building this, I was looking for more convenience so we could have the same operations. We wouldn't have to rewrite them over. It's one of the things that bugged me about the code base is you have the same implementation 20 times, and I was trying to limit some of that. I also wanted to have it enable a lot higher performance, so it's easier to high performance code and to be more robust. Because as we all know, the only code that doesn't have bugs is code that you didn't write. So there's been this is another 2 or 3 years in work. It really went in parallel with Transaction Box. A lot of this was built to support Transaction Box. I actually ended up with some other internal customers in Yahoo. Well, it was a painful experience, but it really improved things. So we've done this. Proxy Verifier, I want to call out to New Brief for help with their RATA. We did some major restructuring there based on his usage experience. So this is not just something that's just come out. This has been in production. It's been used. People have built projects with it. And that's it's distillation of my experience working on traffic servers for the last decade. So as of now, we have now adopted into the ATS core as of 10 dev. So if you're working on 10 dev, libswoc is there. There's a version of 9.2, I guess. It's kind of broken. If people have been paying attention last month, I put a bunch of PRs in, which fixed all of those issues. There are a number of little issues, primarily build related. Got all those done. I would say the biggest change that libswoc is bringing to the community is you can get to this from the plugins. So all that core hotness, all those fun little core features that people used to copy headers over and all of that, you can now just include, right? Particularly the IP address processing, which we'll talk about in a bit. We do have some documentation. This is both handwritten documentation with examples and guides and Doxygen documentation on all of this. There aren't any unit tests in the traffic server code base. Those are all in the libswoc repository. So if you want to go over there, you can look at all the unit tests that are done over there. And I'm constantly adding them. I actually put in 4 or 5 more this week as I was writing my slides and I'd write code. I'd say, does that really work? And the cache has been awesome. This has been tested using cache. I just go over to my cache files, throw in the code, and make sure it compiled and ran. So that has been really wonderful. And of course, it's open source, Apache license, PRs welcome, blah, blah, blah. So if we have issues in the core, particularly before we cut 10, we can fix them, right? It's just another open source project. So let's talk about some little utilities here. Now, one of the things that I've been wanting to do for years and years and years is unify the integer parsing. We have a bunch of different implementations. People do different things. So we now have basically 3 functions here: SD to I to U to D, and SD to radix. So how do those actually work? So the first 3 functions subsume all of the conversions we currently have inside traffic server. One of the big things is the accept views, so you don't have to null terminate. You can just take things directly out. And in particular, where you'll see a performance gain is a lot of people try to copy a number out of some string where there's other stuff around it. You don't have to do that. Get the view of just a number, call SV to I, you're done. So if you're parsing along, you just get a view of just that number. This just works. It handles the radix prefixes, leading sign. It handles overflow in the same way string to L does. You can put an explicit conversion base in if you want. And you can also have it tell you how much of the input it actually parsed. And that's useful essentially for error checking. You can say, hey, did I parse the whole input string? And if you didn't, you can say, oh, wow, that wasn't right. Or frequently you don't care. So anyway, so I started referencing those. SV to radix is originally just an internal template. I ended up exposing it. This is a very low level utility. It's very fast. But if you don't really need it, I would recommend against using it. The other functions are wrappers essentially on top of this. And they handle, so this doesn't handle spaces, it doesn't handle leading prefix, it doesn't have a sign, it doesn't handle any of that stuff. That's all done elsewhere. So I'd like people to start trying to use these things to do their number parsing. I'm not going to talk very much about text view. I've talked about it before. Text view is a subclass of string view, so it acts pretty much like a string view. What it does is it adds a large number of ancillary methods to make text parsing much easier. Has anyone written text parsing in Python? Got a couple of people. This really emulates a lot of the Python work. So there's trim methods. So you can say, I want to get rid of all the spaces on the left side or the right side. I want to drop prefixes, I want to add prefixes on subtract things, I want to get substands. All of that stuff you can do. You can take tokens out. I'll show you a little bit in a sec. Almost all the methods return a self-reference rather than voids. You can say thing.ltrim.trim.contains.empty or whatever. So you can just chain those things up. The main goal when I was actually, yes.
Some of this stuff is going into C++ 20, right? Don't they do trim and all that stuff in there?
I don't know.
I think so.
Well, then check back with me when we move to C++ 20. I have brought a couple of things back. The starts with, I had brought back the start with and ends with from C++ 20. So when I see stuff like that show up, I bring it back into text view. The main thing I started with, this code actually goes back by 6 or 7 years. And what I wanted to do is support non-modifying string parsing of text. So you can have a stream of text and you can do all the parsing, get all the tokens out without changing the text, without doing allocations. Someone was just talking earlier about how expensive memory allocation is. So this lets you just walk the stream of text, not modify it, not allocate. You don't need the null terminations. You don't need to pull these things out. Like for instance, this walk this the SV to I. You don't have to pull the numbers out separately. You can just get the view and parse them directly there. So you don't have to have this token vector where you, like Tokenizer has, where it has to allocate space, put all the tokens in there, and then you go and process them later. Versus string view, it's interchangeable. Simply don't worry about it. Nobody cares. The compiler doesn't care. A conversion is the same cost as a copy because it doesn't have any other members. You can slice it, and it doesn't matter. Just don't worry about it.
Don't you overwrite some of the methods though in string view?
Yeah, but if you have a string view, you should expect to use a string view methods. It's not going to break things, right?
No, but don't you overwrite some of the methods to be different behavior? I thought you did at one point.
There's a few of them that are somewhat different, yes. Okay. Font is small. Try to make the font bigger. I'm sorry. I don't know if anyone can read that. No, I made the font bigger. Why is it not working? Okay, let's see. So this is just quick. So this code here parses the etc. host file. There's a complete parser. It parses the entire file. It handles multiple names for address. And the source is expected to be just literally the contents of the file. That's all you need to parse etc. hosts. No allocations. The only time you're allocating is when you're going in and you're updating your tables about the addresses that you found. So this is fast, it's non-allocating, it's non-modifying, and this is really easy because ahead of this, for the example, I use another SWOC utility, file load, which you give it a file path and it puts it into a standard string for you. And then text use, like string views, just construct date from a standard string, and off you go. So that's kind of an example of power that you're getting out of that. And again, non-allocated. It's not a standard string. If you're taking pieces off, that's really, really cheap, right? It's 2 assignments. All right, scalar, this is not useful as I hope it to be. I use it in certain places to get quantized values. So you can say, if you say, I want scalar 16, which is the example we'll see, the value in the scalar is always a multiple of 16. You say, what if it doesn't work out that way? There's round up and round down functions. So you can take a bunch of numbers, add them together, put a round up or round down around them, and it'll put an appropriate value into the scalar. So this is mainly built for use in the cache where you have a bunch of different size types. So I can define those size types using scalar, and then they're always nice multiples and it just works. So yeah, you're probably not going to use that. So here's an example. This is actually from Memorina. I define my paragraph size to be 16. I don't really need this. It defaults to size T, so but you can have the internal counter be whatever interval type you like. And then I can say, well, if I want to know how big it is, I can take the header size, the content size, trade add them together, round it up, get my allocation size. This is supposed to replace a lot of the shifts and masks and additions that you use to do the round up and round down, to just have it work automatically. And it optimizes that. It uses clever tech, template tech to optimize this. So if you look at the Godbolt output, if you're switching between things that are powers of 2 of each other, it will turn into shifts. So it really optimizes what you're doing there. All right, so this one's a little different. This is SWOC files. It's a replacement for standard file system, because I know Leif and I fought with this for a while. For given the set of compilers we handle and support, standard file system simply isn't all there yet. So I strongly recommend people use this, or if we move to C++ 20, or we upgrade what compilers and OSs we support, then we're going to drop this and replace it with standard file system. And I don't want to hear any complaints about the API on this one, because it looks like standard file system. Okay, the standards committee decided what this is going to look like. I copied it as closely as I could. So when we do switch, it should be very easy to switch. Anyway, so there's SWOC file load, which is actually something I love, because I say, here's the path, you give it a standard error code, and you load it. You get something in the string, or if you don't, then your error code is set to something that tells you what went wrong, eperm or whatever. So I really like that. This also does the standard is dir, is whatever. If you look through standard file system, it's, of course, very similar. Okay, so errata, I should talk more about this. I should have a whole section on this, and we're going to go over pretty quick. Errata is what I'm using for internal error reporting. So it's optimized for speed on success. So if you don't have an error, it's very fast. It's a single null pointer initialization. That's all it does on success. What I really like about it is you can stack error messages. So I can have something, when I get an error, I can make an errata, put an error in, hand it back to someone who called me. They can add another message to it. So you can get some very nice dumps. If anyone's seen transaction box output messages about failed here, failed here, that's just because that's how errata works. Whenever something goes wrong in there, it creates, it just augments if it goes out. So you get notes of, oh, it was this directive that didn't have this key that was in this other directive at line X that was in this with line Q. So you can really just trace down where the things went wrong. You can also find errata sinks. We have to think about that. I know Damien talking about that, which is where an errata gets discarded and not looked at, it can be automatically logged. This is done primarily for intermediate compatibility. So as you're changing, you can generate erratas and still get them logged, even if someone else doesn't see them. There's another associated class called RV, return value. This is a template class that takes a type and returns the type with an errata. So a lot of my functions you'll see are like RV int, RV this, RV that. So if it's successful, I return the value. If it's not, I return the errata. It's tuple supported, so you can use the auto bracket notation to pull the pieces out if you care about that. The key thing here is that the RV automatically implicitly converts into its base type. So if I make a function, here I'll show you in the next slide. So I have a function here that returns an int. I can change it to return an RV int, and everything still works. I do not have to change the call site. So you can put this in fairly gradually. We put some stuff in to make the errata severity codes match the transaction traffic server error codes, but you can also put in standard error code as well. So the errata can have a severity, an error code, and a string. The strings are buffer writer formatted, so you can put all sorts of fun stuff in there, like IP address and whatnot. So that's pretty fun. This is experimental. Sorry, everybody. If you want me to stop on one of these, go ahead. Vector is something I've been working on and off. Something I wanted to do for a long time. This looks like a standard vector. The difference is an extra template parameter to say, make n static instances of the type in the class instance. Why is that important? Anyone want to guess? Fewer allocations, right? What it means is that if you say 6, so you say I want 6 static instances. If you only use up to 6 instances, it puts them in the static area. When you get to the seventh one, it silently and unobtrusively converts to a vector and dynamically allocates the seven, copies the 6 over and gives you the seventh element. So you don't have to check. So if you run over your limit, it just works. There's absolutely nothing you have to do in using the class to worry about that, right? You do nothing, it just works. And the classic case that I always think about when we do this is HT ranges and range requests. We have this vector, we create this list, we do all these allocations to store the ranges. But if anyone's actually looked at data, what is it? 99.99% of the requests have one range in them, right? And that may be a low estimate. So a vector array of size 1 would mean that in all those cases, we don't do any allocation. It puts that one range in the static area and we're done. But if we do get more ranges, it still works smoothly. No one has to worry about it.
Kind of like small string optimization.
Yes, it's inspired by that, right? You want to say, now you don't want to have vectors with large things, and it's not a drop-in replacement for vector in general, because a lot of things you just simply have to, okay, you can't make good estimates. But there are not a small number of places in traffic server where this, if we drop this in, we'll get fewer memory allocations, right? This is the theme. Because I'm a Latham Meyer, he always tells me less allocations. And that's what a lot of this stuff is actually about. We're only allocating when we really need to do that. A lot of the reason people don't is quite reasonably, you have to do all these checks and all this clever stuff to make it work. I'm trying to automate that, so it just works for you. Buffer writer, this is basically my version of standard format. It does some other things too. It can use effectively interchangeably with standard format. It has the same brace notation, it takes the same formatting arguments because we both stole from Python, so it's really Python formatting. But it's optimized to fixed buffer outputs. So we have a lot of places in traffic server that we have fixed buffers we want to write something into. And so buffer writer lets you do that very fast with nice formatting. It doesn't have any printf problems. It uses the template to say, I know what type it is, so I'll figure that out for you and do the right thing. So if you drop an IP address in there, it gets formatted. You don't worry about it. Okay. So any quick questions on any of that? You all absorbed it, right?
For the thing you just shared, buffer writer, I think there's a debug version of that. There, am I right? In traffic server, like a debug.
Well, one of the things I've been playing with there, I'm not sure it's ready for prime time, is creating a thread local standard string, because buffer writer can actually write the standard string. Use the two-pass approach where if you do a buffer writer clips your output to the buffer size. So there's a lot of places we're doing all these checks to say, am I passing on the buffer? I'm passing on the buffer, over and over and over. Buffer writer, you just write to it, and when you hit the end of the buffer, it stops writing. But it also keeps track of how big the output would have been. So the string printer version tries it out on the string, whatever size it is. If it's big enough, great. If it's not, it resizes the string and runs again. You put a thread local standard string that you use for all of this. There's no thread contention. And eventually, quite rapidly, the string gets pretty big. And then all the other subsequent ones don't do any allocation, even though you're putting in the standard string. Yeah, the downside, of course, you have to use it immediately because someone else might use it the next line. But there's a whole lot of debug messages you want to generate. So this works really well. All right, so we're going to go a little slower now for the IP networking. This is really a big part of where we're going. So what you'll see if you look through these classes, that they frequently come in triplets in this implementation. And the triplets are what you'd expect: B4, B6, generic. You see there's actually some of this. If you look in inet, there's some IP adder stuff now. It never was well developed enough to make me happy. And libswoc is a refurbishment of that to make it much better. It's almost where I want it to be. The generic form is generally when you're not really sure what family you're going to be using, and then you don't have to worry about it. It knows what family it is. I'm hoping that eventually all of inet will disappear and be replaced by this. So, and again, for people who've written plugins that stole inet, you can link to this from the plugins. So first we have IP endpoint. This is really just a wrapper for sock adder. It's a union, so you don't have to do funky cache to get the sock adder in or sock adder in 6. You can just .sa.s4 S4, S6, I don't remember what it was, get the address of that. This is used when you're directly interacting with network system calls and you actually need a sock adder. It has some extraction functions to say, oh, get me the port. And again, it handles the family for you. So if you say get the port, it knows whether it's a V4 or V6 and gets the port in the correct way. You don't have to check for any of that. So that's nice. Let's see, IP adder. So this is our base class. Of course, there's 3 of them, adder, 4 adder, 6 adder. You can construct them from a whole bunch of things, from sock adders, from endpoints, from strings. So it does all the standard network address string translation, handles the brackets for you. It has methods to say, you can say, is it loopback, is it multicast, is it any, all of those. You can just ask for that. So when you're doing parsing, if you notice when we're doing the host thing, I used IP adder to parse the addresses. So it handles V4 or V6, sets itself correctly internally, and then you're all done. There's methods to check whether it's a V4 or V6. So this basically, now this doesn't interact, only IP endpoint interacts nicely with system calls. All the other ones are mainly for performance and convenience. So you tend to convert back and forth. If you're storing things, you really want to store it as an IP adder rather than a sock adder. It's a lot smaller. Okay, this is Rob Butts. I'm sorry he's missing. He bugged me for literally a couple of years about this, and I finally put it in, and then he leaves me. So what this is this is a combination of address and port. And I don't like the name, but I couldn't come up with a better one. So it just lets you put an address and port together. It does the parsing for you. So if you give a string, address, port, it does it for you, figures out the port, puts it in. You can put just an address in if you want. And this isn't going to be used that much early on. Hopefully in the long run, we're going to start converting the hosted to use more service-oriented things. That was a big complaint, that if you have a host, it can be down on just one port, not the other, and we can't really track that. So eventually we're going to use this, but as long as I was rewriting things, I went ahead and put it in. So that's more of a future class. I also ended up adding these. I'm not sure I'm generally used for other, for the stuff that I work on, these are extremely useful. So yes.
Are we mixing TS namespace and SWOC namespace here? What's the deal?
There's a SWOC namespace and a TS namespace.
But isn't this all about libswoc?
Everything's about libswoc.
But shouldn't they always be SWOC then? Why is it TS?
Oh, okay, right. All right. Excellent question. Sorry, I was spaced out. So these are only in traffic server, not in libswoc. Okay. These are written on top of libswoc for very, they're not general enough to really go there. It's really only traffic server that finds these useful. So what these do is contain 0, 1, or 2 addresses that are equivalent. And this comes up when you're parsing something like proxy port addresses, where you can have a V4 address or a V6 address, or both. Well, actually outbound addresses, right? You can have a V4 or a V6 or both. And that models this. This models that. So that you can have a V4 address or a V6 or both in there. Use the standard optional internally, and then it does that. So if you like get best adder, this is an excellent example where you say, okay, I've got this name and I want the best adder for it. And if there is a V4 and a V6 where you like to return both, or just one, right? Whatever. And so you get an adder pair back, and it has one or both or neither. Yes.
So are these namespaces and classes and whatnot, are they exposed to plugins too?
Yes.
How? How did we do that? Because these are C++ files, right?
Right. I put them in include tscpp/util.
So this was so we're mixing shit into tscpp, and we talked about getting rid of tscpp.
No, you're talking right in tscpp/API.
That's not confusing at all.
Well, once we get rid of API, it will certainly not be confusing. I mean, we've already had, as of 9.0, we put like TextView is out there. I know Walt put a couple classes out there for plugins to use. So that's been around for a while.
So when I do make install, do I get include/tscpp?
TSCP util, yeah. Well, actually, you get both. You get the API and util when you do make install. So what?
Oh, is this like dynamically linked, statically linked, either one?
I went back and forth on that so many times. I'm feeling it. I believe at this point, libswoc is dynamically linked.
Yeah, so that would, I mean, if we have version compatibility problems, then it would be good if we could statically link it into a plugin to bypass that.
Yes, you can do that. So again, if you want to use a different version of libswoc, just like OpenSSL, I'm not an OpenSSL and YAML. Actually, I'm very strongly in YAML CPP. You can replace the libswoc and traffic server with your own libswoc if for some reason you want to do that. And you can also statically link it in your plugin and have it different in your plugin than it is in traffic server, if that is required. So now we go to IP range. Well, it's range of addresses. It's a yes.
So where does SWOC show up then in the
Include SWOC.
so why is that not in TSCPP?
The TSCPP is stuff that's ATS core.
Okay.
The include SWOC is identical to you get if you just had libswoc independently.
It goes in where?
It should go and include SWOC. If it's you're on 9, it may not work.
I'm in
10
10.
dev,
No, not 10 dev.
then yeah, it's probably not going to work. It works in 10 dev.
It's only in 10 dev.
Yeah. Someone told me don't put too much stuff in 10 so it's easier to merge and backpatch.
Sure. Well,
No, I tested that. I'm confident it works in 10 dev. So naturally the ranges are a single family. You can't have, it makes no sense to have a V4 to V6 range. It parses those various formats, min-max, adder flash, mask, and just a single adder, in which case you get a single SIM range. So there's your ranges. Let's see, what else we got? IP space. Now this is the big one. I love IP space. Boy, I put a lot of work into hit this. And who's used IP map? 2 people have used IP map. Yeah, 2. Great. Glad it doesn't work again. So this is not, this IP map is really ugly. I never liked it. It was a dumbed down version of something that was more complex back in the day. This, and you had to use weird pointer things, really painful. This is an STL style container where the key is always an IP address, and you have any data type you like as the payload, right? So your value type is whatever type swings your boat, right? It handles V4 and V6 simultaneously. It's range based, so if all you're going to have is single addresses. This will probably work, but it won't work really. It'll work okay. It's not great. It's really optimized for ranges where you have potentially billions, or if you're doing V6, quadrillions of addresses where you could never put them all in a map. So it's very range oriented. And I also want to point out it's range based, not CIDR based. Right, so you don't put networks in there, you put ranges in there. The range happens to be a network, great, but there are no network restraints on this at all. It's pure, it's a range, any address, any other address.
I'm still confused on your namespace. Why is that in the TS namespace?
Which one?
This adder set.
Because it's not in libswoc.
Why not?
I didn't think it was sufficiently general to be useful in libswoc.
It says ranges of IP addresses.
Oh no, wait, range?
No, IP adder set.
There, right?
I don't know what it says there, but I see
It's
this.
one before this.
Yeah, here.
No, it's pair.
Oh, down IP address set. Okay. I thought of, oh, there we go. Yeah. I thought about that. I might put that in there. I was kind of in a hurry. I just added that like 2 weeks ago. So I'm still deciding what to do about that.
I think we should aim to be more consistent here. Like if it's really not ATS specific, and we already decided to drag in libswoc, right? So that's sort of both already sailed. Then we should be consistent and so we know where the hell to look when blame.
Yeah.
Particular blame.
I'm not sure I like putting the adder pairs in libswoc. They're really kind of very specialized for traffic server.
In what way?
Who else is going to do that?
But do you have other IP stuff in libswoc, right?
Yeah, but that's stuff that I consider to be almost anyone doing IP address work is going to use. I guess we can look at moving it. PR is welcome. I may end up moving adder set to libswoc. Adder set is a simple wrapper on IP space. It gets rid of the value type, right? So standard set versus standard map. So there's a lot of places where people use IP map only to track the addresses. So IP space, let's talk about that a little bit first. Range space, big and fast. The Yahoo DNS has used this with well over 10 million ranges with still sub-microsecond lookup times. So that's plenty fast.
Wait, so IP space is in libswoc, but the
Adder
other
set.
one, the adder set is,
It's just a simple wrapper. That one I would consider moving up because maybe just until I went back to work on traffic server, no one had a use for it. Everyone wanted a payload. All the use cases needed data with it. But we can move that one back. That's not on object list of that one. IP space. Whoops. Where do we go? I want to go forward. Okay. So the way this works is there's 3 insert methods, 3 ways to put ranges into the map, and they differ in how overlaps are handled. So if you have stuff in the map and your new range overlaps it, there's 3 different things you can do. If you do say mark, the old stuff is wiped out and overwritten. If you say fill, it skips the parts that are already there. And fill is nice if you're parsing config files. This is how IP allow works. It just takes each range and fills, so that if you get to a later range that covers parts of the previous range, those previous parts don't get written out to the IP space. Blend is a more obscure thing. It lets you blend the overlapped regions. This is very, very important to the Yahoo DNS team, which are just getting endless problems about this. So that one got really developed, but what they were doing is they were blending multiple GeoIP databases. So they would take between 3 and 4 GeoIP databases and put them into a single IP space, and then they do 1 lookup instead of 3. And then they could cross-correlate the data where it differed. They could get notes on, okay, well, this map said this, that one said that. They can make judgments in generating a single unified map. You could use it for error detection. If you have allow list and deny list, you can detect that they collided and generate an error. Honestly, I don't think we're going to use that a whole lot, but
wait, so what does blended do then if it chooses a?
no, what you get a functor. And if there's an overlap, it calls the functor saying, here's what I've got in the map now. Here's what you told me to add. Change it to be what you'd like. And you could just, if you're doing, the error check, you could just generate an error message there and just say, yeah, it's fine, whatever it is, right? Okay, so here's a networking example. What the heck is this doing? Parse IP map. All right, so this is parsing a list of this actual code that's in there now. It's parsing a list of IP addresses, comma separated. So we go in, we clip off the left space, then we pull out a token. So the take prefix at says search forward until you find a comma or you hit the end of the string, then give me all the stuff that you found, and then throw away the comma. So this pulls your comma separated tokens out one by one, boom, boom, and then we trim this. Then we trim the space on the right hand side. So trims can take characters or they can take functors. I'm using functors here to say call is space and see if it's a space. And this is what here is really nice. I want to load a range. I just take the token, I call load on it, and that returns true or false. If it returns true, that means hey, that's a valid range. I stick it in the IP adder set, and off we go. And so that gets, there's an alternative one down here where you could declare the range and with the constructor do the parsing and then see if it's valid. I like the other one better, where you just declare it as default and then load up. So this is what the original looked like. With IP map, you had to have your own min and max. You had to parse those out. You had to do this IP range parse. And then you had to do the fill, and you had to pass a null pointer because that's just the way the API worked. And it's somewhat better. You really get when you start using payloads on, you see a lot more power there. All right, so that's IP network. So that's the direction we're moving in the core and plugins for how to handle network address data. I think it's a fairly complete set of operations and containers to make all of that stuff very easy. Especially the parsing is really nice. Again, Buffer Writer is fully aware of all these IP addresses. So if you send any of this stuff to Buffer Writer, it gets nicely formatted up and you're all set, right? No calling those 8 INET P and all of that kind of stuff. just pass it to buffer writer and you're done. So now we're going to talk about memory handling. Chris is here. So we're going to talk about memory handling. This is going to be much more of how do you do it using libswoc. I'm not going to talk about a lot of theory because we're going to talk about that. First, we're going to talk about memspan. And actually, I'm working on that right now, doing an upgrade. I saw there's a little problem. I'm fixing that. It's a smart pointer. It's like a view, except it's writable. We kept having, I know one of the reasons I actually started building this class is we kept saying I got a view, but I'd like to be able to write at it. Right? I kept getting people complaining about that. Well, memspan. So it's got a pointer, it's got a size, it's writable, it's non-owning. Let me clear about it's non-owning, so it's really cheap to copy. It's got a rebind method that lets you cast to different types, especially like an array. We've got overloads for memcopy, memcomp, and we have support for alignment, memory alignment. So you do something like this. Here's how the original one, the new one. So you pass this char star back. You pass a char star name length in there, and another length, which is a reference to get the length of the thing back. The new version, you just hand that to memspan. Well, here's your pointer length. You're done. And pass in, well, you pass a string view in or a text view, whichever, to get the, then you don't have to be confused about which length is when. So you don't have to have a reference. And you can put this in an if. Right before you have to declare something earlier and then do the if. This you can declare your whatever inside, memspan thing equals fine if memspan, memspan not empty. Then so that's a lot nicer. If I have to have things together all the time, I like to just put them in the same class. So
Okay, that's fine. Well, when you say, I think of a smart pointer as implementing some kind of ownership semantic, but this is not.
when I say spot, yeah, I need a better term. What I mean is it's not just a raw pointer. That's all I mean by that. One of the places one of the
location in length. So it's adding.
One of the places I have strong disagreements with the C++ standards committee is that for me, string view, text view, and memspan are smart pointers or fancy pointers. They're not containers. And there's a lot of things that go wrong with string view because the committee seems to think it's a container and it's not. It's just a fancy pointer. So all of these, so like text view, you can do ++ on it to drop the first character. You can do that on memspan too. So to me, they are pointers with extra features. Now, one of the things I like for memspan, which I'd like us to start using, is that you can make your functions more generic. I see a lot of interfaces and plugins and whatnot where you take a standard vector. If you take a standard vector, that means someone has to allocate the vector. And then if it's a subpiece of something else, they have to copy it into the vector because you can't have the vector sit on top of someone else's memory. So if you have a bigger buffer and you want to process a subunit in it, you have to allocate the vector, copy it over, process it, and then copy it back. Right? It's just ugly. If in fact, instead you accept a memspan, then they can use a vector, they can use a buffer, they can use part of a buffer, they can use an array, they can use a raw pointer and a length. All of those work exactly the same. So we've really genericized what you can pass in, what you have to have on your side in order to call the function. All you need at this point is something, a pointer and a length, and that's all you need to call the function. Everything else, whatever memory arrangement you like and works for you, works best. Again, trying to minimize required memory allocations, right, to be more flexible. Well, yeah, you can pass string views in here too, right? String views or text views. It's a memspan of char const. Now we're gonna get to fun stuff. Your turn, Chris. Off phone. So memory. So I have to talk about memspan first because memory relies heavily on this. So this is a memory allocation arena that Chris was talking about, that kind of thing. You can't really deallocate anything in the arena. You can only deallocate the arena, right? When you destroy the arena, everything goes away. So as we said, users have lots of small allocations and pretty much everything's going to die at the same time. If you quote leak unquote a bit and have some things that don't go to the very end, that's fine as long as it's not huge. And then you just get rid of everything. This is loosely based on the existing class arena, and also, of course, well, TS memory is based on the old arena, and the SWOC memory is based on TS arena. So then some of the big differences is that we can allocate anything we like in the arena, not just strings. The internal memory block handling is much better in terms of it tries to limit how many blocks it has. It has a mark for full. So once you have less than, I think it's 16 or 32 bytes left, it doesn't look at that memory block anymore. So you have 20, it's only going to look at like 2 or 3 just to look for space. So the current arena looks all the way back. It's really inefficient. I'd like to put this in the state machine. So we talked about before for core and plugins to use. So you can just allocate transaction lifetime memory. So we have template allocators to constructors. So equivalent of new, we can do alignment. There's some simple generation of garbage collection support. There's transient storage access. I'll talk about that in a bit. I stole that from Arena. There's static block support again, trying to minimize allocation. So you can seed the arena with a static block of memory, and it'll use that until it runs out. And if that block is big enough, what's the result? No allocations, right? Again, this no allocation, memorized memory allocation is a major theme of this whole library. And so I'm going to keep hitting on that. And you can self-contain it, which again can be used to minimize memory allocations. Have you seen that, tried that yet, Chris? Yeah. Anyway, so one of the things that helps reduce memory allocations, because that's a big theme, is this transient memory. So if you have this kind of memory, you have blocks of memory, and there's unused space in those blocks, right? So it's kind of nice to be able to access that space if you need something very transient. This, particularly for string construction, is mostly what I use the transient memory for. If I have to construct a string and then pass it to someone else, it's really nice. Put it in the transient, pass someone else, they return, and then I'm done, and I leave the memory and it gets reused. The Arena class, I stole this from Arena because it has the ability to unallocate the most recently allocated string, which is really kind of odd. I said, don't do that. We'll just give you direct access to the transient buffer. You do have to, you can also tell the memory that I want a transient buffer to be at least K bytes. So you're going to guarantee a transient error at least of a certain size, you can just do that. So you can do this memory use and again reduce allocations. There's intrusive. I haven't talked about these in libswoc. I think they're in the core. They're also in libswoc. So intrusive containers, lists, and hash maps. And the memory news work great with intrusive lists because that puts everything into the mem arena. And then when you dump the arena, the whole list just vaporizes along the arena and there's no cleanup. So you have to be a little careful. What generally what you'll see in my stuff is I'll have an intrusive list and I'll localize strings. Localizing string means I copy them into the memory. So all my list elements that have strings point to have views of strings that are in the memory, and I can just drop the whole thing when I'm done with it. But we can allocate other stuff in there. Transaction box. Sometimes you have to put stuff in the memory that you really can't just be disposed of summarily. So transaction boxes comes with the finalizers that you can add just little functors so that when you clean up, you call those and they dispose of things. So this actually came up. I was at LinkedIn. They were doing a concurrent container. The goal here is to have a hash map with IP addresses in it and have a limit on the number of entries and LRU them out. So I used an intrusive hash map and an intrusive list with a memory. They use TDB with their concurrent hash and concurrent list. And the performances are about the same. And my analysis of this is that because I use intrusive stuff, I can move the construction destruction outside of the locks. So when I delete something, I just pull it out of the container, which is just like 4 memory operations, stuff it locally, and then after I drop the lock, destruct it. So that was some pretty good performance without a lot of extra overhead. So that was fun. That's actually, you can actually look at that. That's still on, it's an example in the libswoc repo. The stack, we talked about this. I'll just skip over this. Permease, again, if you usually don't use a lot of memory, you can put in the 2K or 4K static stack block, use that and only allocate again conveniently, right? The memory just takes care of it for you. When you run out of static space, you cleanly get new heap space and it just works. So that's the kind of convenience and performance I'm trying to get out of this. So you can do garbage collection. I don't know, probably no one. I want to use this for header heap, which is why I put it in. So you can freeze stuff so that the existing blocks don't get allocated for anymore. Then when you allocate, it'll create a new block as big as all the other old blocks, and then you can override that. Then you would copy everything back from the memorina to the memorina, and then thaw it, and then all that old memory goes away. And this goes to locality thing too. If you have a bunch of scattered allocation blocks in your arena and you do this, they're not all sitting in one block. Right. I want to use this for header heap so that we don't have to coalesce. Because the way header heap is written, you have to coalesce when you run out of space. You don't have an option. This one we can say, well, we'll just waste some more space, and then after all the plugin hooks are done, then we'll coalesce. So you don't have these pointers magically changing on you. I know a lot of people have had crashes from that because you get an M-lock and you do some other header operation, suddenly your M-lock's pointing at the wrong place. So anyway, look at that someday. I also wrote a fixed Drenosis for wrapper that says I'm only allocating T instances, and it keeps an internal free list so that if you create a T, you can delete a T, and it's just stuck on the free list. IP Space uses this internally to do all of its object management. So it allocates that way. Because if you're adding stuff, it can have delete existing ranges and put ranges back. And this is the fun one. So of course, Loom Arena has move construction. So you can create an instance and then move it into the arena itself so that it owns its own memory. Why would you want to do this? Can anyone guess why you want to do this? What was the big theme? Less allocations. Thank you. So this works two ways. First off, if you can do this, and you don't have to declare a memory at all, you just declare a memory pointer. And therefore, there's no way you can allocate. It's just a null pointer. And then you don't actually create and invert the arena until you actually need it. And these things go. It's frequently the case that if you wait long enough, you won't need it at all. There's lots of cases where it just may turn out you don't need to do this. So you don't have to do it preemptorily. You can do it very lazily. And hopefully, a lot of cases where you never get to that. Yeah. So the memory structure is implemented as this word. You have to be a little careful. We'll talk about that. So this is the way it works, right? You declare it on the stack. It allocates the memory on the heap. You move it. The thing on the stack, it's cleared out, so it doesn't own any memory. The memory in the heap, in the memorina, owns the memory. So errata uses this. When before I did this, errata, if you had an error condition, would actually do 3 allocations. You have to allocate an internal data object. You have to allocate its own arena before memory supported this, and it had to allocate a list of the nodes. After I updated memorina this way, now it only does one allocation. It does the create on the stack. It puts its data object in the memorina. There's a memorina member, which then moves the memorina into, and then it puts an intrusive list in that memory. So we now, instead of 3 allocs, we're doing 1. Okay, that's the kind of thing that you can get away with. So you have to do a little bit of work. So you can't delete the memory in this case because you'll double 3 because it's in the memory. So there's a bunch of different things you can do. You can look and test memory. All of these they're examples of all of these. They're all really the same thing, just different syntax depending exactly how you want to implement it. Okay, memory and PMR. Well, I put the PMR support in memory in it. It seems to work, but you can't use PMR on CentOS 7, and we support CentOS 7, so ain't happening for you. Tough luck. And one last thing. This is the last thing. I'll go through this pretty quick. Lexicon is another thing I wrote. This is one of the new classes. Almost all of these are been retreads. This is new. This is a bidirectional table, like a hash map, except it goes both ways, keys to values and values to keys. And this is intended to support enums. So one key is the enum value, the other key is a set of names. So if you put a name in, you get an enum. Put an enum in, you get a name. So that instead of all the crazy lookup stuff and the arrays and all that, you create lexicons. And then
how does this compare to magic enum? Have you seen that header file?
Yeah, we looked at that. This requires more setup, but it's more flexible.
Because I know Magic Eden is that it's all const. It's basically it's a lot of it is just compile time evaluation.
Yeah, this one, yeah, this actually does lookups. So one of the things you can do, one of the things I don't think Magic Eden can do is this. So here's an example of that actually using transaction box. So we declare an Eden bool tag, which has 3 values. We declare a lexicon for it of bool names. And say, so for bool tag true, here's a list of names. And for bool tag false, here's another list of names. So any of those names, so if I say, if I put disable in, I'll get false. If I put on in, I'll get true. So the first one here is called the primary name, and these are called the secondary names. And the difference is if I put in true, I'll get the primary name. If I put in false, I'll get the primary name. And Chris made me put in something so you could iterate over both the primary and the secondary names. And then, well, there's the parser. I say bool names, give it the string. And if that's true, it's true. Otherwise, I set it to false. You could do an error check here if you cared about invalid ones. Also, the lexicon, this argument here says that if you don't find the enum, return this. If you don't find the string, return this value. So you can put it in default. So you can also put a default in the other way to say if someone gives me an enum that you can't find, return this string. And this is designed to be, and you can see it's const. So you can set this up beginning of time, constant, and it's just, and there it is. Oh, don't do that. Looks like you're raising your hand. So yeah, I really missed this class. One of the other big motivations was, of course, Leif, because he complained about really ugly code I put into recconfig. Where is that? The enum handling in for configs is really painful. So this is designed to make that much simpler. So rather than having to do all the grungy stuff, you can just put lexicons in. And notice that updating these is really easy, right? I'm going to put some additional values in for true or false. How hard is that? Just stick them in the list.
It's actually very common use case.
And here's a fun example that I wrote just because I want, this might end up in traffic server 2, although I'm not sure yet. Unit parsers. So the whole concept here is that you want to parse a string, which is a combination of numbers and tokens. And the tokens indicate multipliers. And we have like 5 or 6 implementations of this inside traffic server. So I'd like to unify them using this. So here we go. So one way you can do it, you could do this for memory size. So I say, okay, well, if I see the tokens B or bytes, I'll multiply by 1. If I see these tokens, I'll multiply by that. So now we can parse strings like 10M, 256K, 384, or 10 megabytes, 250 kilos, 384 bytes. And those get parsed out as the correct number of bytes. So some of the stuff that's in config, in our current records config, some places do this and some don't. And some of them do it slightly differently. But this will let us unify all of them into one simple one. And again, updating the table, we don't have to go to a lot of code or anything. If I want to put terabytes in here, how hard is that? Right? I'll put one more line and I put terabytes in. I want to have different names. I just put those in. This thing here says you don't have to have a unit token. So that's why the 384 here works. And the 111. So those all just work. And it doesn't require order. This works too. And we can do time. This is why I put this in for Dave Carlin, because he was complaining that transaction box didn't parse time strings very well. So the nice 12-hour stuff, all of that, this is how it's done. So again, we just put in our, how many nanoseconds we want for the values, and we put in the names we want for the various time units. And then you can parse stuff like this. Oh, that's it. And this is an example again in the libswoc EX unit parser, and it's about 100 lines of code. The implementation of this is only roughly 100 lines of code because it uses lexicon, right? You set this lexicon and then it's all really easy. So again, convenience, right? Once you set this up, it's so easy to change all of this, right? Just add new names, remove names, whatever you like. So that's about it. I'm sure it was so complete that there are no questions.
Well, I did look, there is a debug underscore BW for buffer writer.
Yeah, I think that's a standard string. Oh, no, is it? Maybe it is.
It doesn't have the thread local thing, but for the developers here, if you want to sell that, why should developers use that instead of the formatted printf formatted string version?
The number one reason is to not call ancillary formatters. So, for instance, if you want to print an IP address, the way you do it in buffer writer is you put a open close brace in and you pass the IP address. You want to print an IP range, you put an open to close brace, you pass the IP range. You want to print a lexicon, open close brace, pass the lexicon.
Or text view.
Or text view, right? You don't have to do the dot star stuff. You just say open brace, close brace, pass the text view, pass the string view, pass the string, right? No .c string stuff. You can also, it's got a lot of formatting options. So if you have memspans and whatnot, you can actually control how it dumps that. So it becomes very easy to dump hex memory. Because I want to print this in hex. I want to put the contents of this in hex, and then you get a hex dump of whatever memory. So the number one reason is that the formatting is way easier, right? And this is what standard format is also about too, is that you just don't have to worry about it. Now you can control the format. You can say I want a capital, I want a lowercase, I want width controls and all of that. But let's be realistic. How many people ever use that in printf either, right? So it's available and it works, but it's not a big selling point. The real thing is, it's extendable. So if you have a type, and actually do this quite a bit locally, is you write a method, a function called VW format that takes your type, and then you write the output. And then from then on, anytime you use a brace and pass that type, it just gets formatted, right? Damien was saying, well, I have to loop the errata, right, to get all the messages. No, open brace, close brace, pass the errata, pass the error code. Like for instance, if you pass an error code, it'll look it up and it'll say error, like
The error knows.
E unavail, 2. It'll just do that for you, or not available. You can just control that. You can actually, there's some formatting options on that. Control whether you get the long form, the short form, or both, right? And you don't do anything, just pass it in. There's some fun stuff where you can wrap it with a date. There's a fun if construct, and you can say, you can wrap things with if, give it a value, and then a default. And if the thing is there, it prints it, otherwise it prints the default. And so you don't have to all these conditionals or, if this print stuff. There's really a lot of powerful stuff. I didn't want to get into it. So that's really a lot of fun.
If we wanted to use it more, are there concerns about performance with it? Like if
I don't think so. My testing indicates it's pretty fast. And certainly faster than doing things like allocating memory, calling inet p to n, getting that, copying that back in, and then printing that. I guarantee it's faster than that. Buffer writer also supports extractors. We don't use that inside traffic server, but you can do brace, thread, brace, and you don't pass any argument. It'll go find the thread ID and put it in the message for you.
Regarding the performance part, since you said it's fast, have you done any benchmarking in terms of how fast is it compared to other methods? Or
I compared it to printf, and I got within 10%. I'm sorry, SM printf. That was primarily for numbers. So generally, if you're printing stuff, you've already sacrificed some performance, particularly for error messages. I guess I could test it against the inet to p stuff and see if it's any faster than that.
So I did benchmark it against FFT. There's a GitHub issue on that.
so if we do changes in ATS, let's say if you start using libswoc for some of the things, do we expect like the ATS's performance to improve by a certain percentage?
I think it should improve. I don't know how much measurable that'd be. The number one thing that I would say would give us performance improvement is using these to avoid allocations. I don't know how I can emphasize that more. And I know that LinkedIn, you guys spend like 50% of your time in malloc and free.
Yeah.
So this is that's where you're going to get your performance benefits. Stop allocating, right? Number one thing I would say for you, I guarantee that buffer writer is faster than that standard constructing things with standard string addition. Absolutely 100% guarantee it's an order of magnitude at least faster than that, right? And I saw that everywhere, right? Because they're using standard strings to do. You've seen that, right? They declare a standard string of thing and they add another standard string and another standard string. You're doing dozen allocations right there, right? Guarantee buffer writer will beat the pants off that, no sweat, and be easier to use.
Well, aside from the performance issue, like any performance issues, it's just like we want to do things one way. This is a step towards doing that. We don't want to keep reinventing the wheel all over the source base and make it harder to understand and bigger.
Yeah. Now we haven't decided what we're going to do in the future of buffer writer versus FMT. However, the syntax is almost identical, right? I tried very hard. We started out close because it was fault from Python, and I've made some additional efforts to make it similar. So if we decide to change in the future, it's just really not going to be a big deal. It's another reason I was trying to make using buffer writer, because I can guarantee you we're either going to switch to buffer writer or we're going to switch to standard format. One of those is the future. And so you should just get used to the syntax and the format now.
Yeah, there's some things in FMT that you can actually do, like compile time optimization and stuff like that. So
Yeah, there's some cost to that too. Leif didn't understand that until he tried to do it himself. Now he understands, but because they use a somewhat different system. The main thing, I don't know how much we get into this there. For me, the main thing is the ability to insert names for lookup in the strings so that I can have Python-like extractors. So if you're in Python, you can put brace name and it'll do a lookup on that name. Buffer writer takes that same concept. So you can say, you can inject into the buffer writer processing, here's a table. When you see this name inside braces, call this format function. And that lets you insert things and have general, like the brace thread or the rate, like time. You can put time in there so it automatically gives you the timestamp or the various other IDs. I don't know if that's possible with standard format. But this is kind of inside baseball. Again, we're going to move to one of those two. And it's unlikely you're going to hit the very edge cases or the formats differ. So, and they're going to work pretty much the same way in terms of what you output to. So I recommend switching over. All right. Well, I'm sorry, that was kind of a rush, and I you see a lot of glazed over eyes, but hopefully it was gave you some exposure to where we're going and what's now available to you.